In this video, we're going to summarize the Math 1 lesson titled Cafeteria Actions and Reactions. This is a develop understanding task. The purpose of this lesson is for students to develop strategies for creating, solving, and explaining each step when solving an equation. Elvira is interested in collecting data about how many students use each of the tables during each lunch period. She has recorded some data on Post-it notes to analyze later. Here are the notes that she's recorded. Elvira is wondering how many students were sitting at the front table when she wrote her first note. Unfortunately, she's not sure what order the middle 3 Post-it notes were recorded in, since they got stuck together in random order. She's wondering if it matters. We need to determine how many students were originally sitting at the front table. I want to approach this problem first with a diagram, and then the video will take you through how you could set up an equation. But let's just start with a diagram to make sure we really understand what this problem is asking and how to model it. We start at the end because this is the only place where we know exactly how many students were sitting at the table. So let's start with a diagram. So here I have the lunch table, and then I put 12 students around it. So I'm going to write down that there are 12 students at this table. And let's look at the sticky note, what happened right before that. The students at the front table separated into 3 equal-sized groups, and then 2 groups left early, leaving only 1/3 of the students at the table. That means that a lot of students left, and the remaining were 12. So 2/3 left, 1/3 stayed. So that means we need 3 groups of this 12 to be sitting at this table. So we have a group of 12, and then another group of 12, and then the third group of 12. So that's a total of 36. All right, let's look to see what happened right before that. So at this point in time, there were 36. So this says 4 more students have just taken seats with the students at the front table. So if we're working backwards, that means that there would be 4 less. So that means there are 32, total of 32 students. Each of the students at the front table has been joined by a friend, doubling the number of students at the table. All right, so then that would be 16, because if it's doubling, that means we'll just have to divide it into 2, so every other student wasn't sitting there. So these are the students that join. And so our answer to this question would be 16. So let's just go back through and make sure that this makes sense when we're doing this forward, since we were having to undo everything to work backwards. So some students were sitting at the front table. We'll say there's 16. Each of the students at the front table has been joined by a friend, doubling the number of students at the table, which means there would be 32 because everybody had a friend join them. Then after that, 4 more students have taken a seat. So we're adding 4. So that would be this 4 right here that have now just sat down. All right, now that we have a total of 36, it says the students at the front table separated into 3 equal-sized groups. So there's our 3 equal groups. And then 2 of the groups left, leaving 1/3 of the students at the table. And that means that there are a total of 12 students there at the end of lunch. All right, so let's look to see how we could represent this algebraically with an equation and symbols. The first thing we're going to want to do is define our variable. So x needs to represent the students that were originally sitting at the front table. So students originally sitting at the front table, that is what x represents. So a number of students. All right, whenever I want to write my equation, I'm going to start at the beginning. So some students were sitting at the front table. That is going to be our x. Each of the students at the front table has been joined by a friend, doubling the number of students at the table. So if they're doubling, that's multiplying by 2. So I have 2x. And then 4 more students have just taken seats at the front table. So we're adding 4. So we have 2x plus 4. And then we had to divide that by 3 because 1/3 is remaining. Since 2/3 left, 1/3 is remaining. So we want 1/3 of the number of students that we have. So that is going to be 2x plus 4. Well, we have a 4 divided by 3. And that equals 12. So let's take a look at how to solve this algebraically. When we first found the answer, we had to work backwards. And that's the exact same thing that we do when we solve an equation. We work backwards. So the first thing when we were working backwards is we had to multiply by 3. So we'll do the same thing. We'll multiply by 3 on both sides of the equation. So that gave us our 36 students at the table. After that, we had to subtract 4. And that's what we'll do here, subtract 4 on both sides of the equation. The next thing we did was we divided by 2, which again we'll do here, divide by 2, and our answer was 16. The only thing that I did here was I rearranged these two sticky notes. So let's do this problem the same way we did the last one. Let's start with a diagram, and then we'll set up our equation. Again, as the lunch period ends, there are 12 students seated at the front table. Before that, they had split into 3 equal groups, so we have a total of 36 still right here. Let me record how many that we have. There were 12 here and 36 here. Now, the difference in this problem and the last one is that this is when the students have doubled. So they doubled to get to 36, so we have to divide by 2 to get the amount that we had before, a total of 18. And then 4 more students, so we have to take those 4 off, subtract those 4 out, and we have 14. So as you can see, 14 is different than the 16 we got with a different order. So does it matter which order the notes were recorded in? Yes, it matters which order the notes were recorded in. We rearranged them and we got a different answer. So let's take a quick look at setting up the equation. So again, we have to identify what our variables are going to represent. So define what the variable's representing. So x is going to represent how many students were originally sitting at the front table. So x is going to be right here. Now this time we added 4 first as we went from 14 to 18. So we have x plus 4. Now, everybody has a friend joining them, doubling the amount. So 2 times the x plus 4. And after that, we divided by 3, and we had 12. So when we solved this equation, we started with multiplying by 3. So 2 times the quantity of x plus 4 equals 36. And then divide by 2 to get the 18. And then subtract 4, subtracting 4 on both sides of the equation to get 14. So here are 3 different equations that could be written based on a particular sequence of notes. Examine each equation and list the order of the 5 notes that is represented by each equation. Find the solution for each equation. So this right here should look familiar, and this last one right here should look familiar because that was the first example of the original way that the question was ordered. So let's take a quick look at this one that we haven't looked at yet. When trying to decide what the order is, if you start with the x and then look to see what was done to the x and kind of work your way out. So here, some students are sitting at the front of the table, and then they were separated into their 3 groups, leaving a third of the students at the table. So it's divided by 3 first. And then 4 students sat down, and then everybody was joined by a friend. And then at the end of the lunch period, there were 12 remaining. So to solve this equation, I want to, again, work backwards. So I start with what happened last, so this doubling. So my first step is going to be to divide by 2 on both sides of my equation. I'm going to represent it like this. That leaves me over here with x divided by 3 plus 4 equals 6. My next step is going to be to subtract 4 on both sides of my equation. So I have x divided by 3 equals 2. And then my last step here, so I'm going to multiply by 3. So I'm going to use parentheses and put a 3 for multiplication. Parentheses around this one, put a 3 for multiplication. That leaves me with x over here on the left and 6, 2 times 3 being 6. So there are 6 students at the front of the table. A quick summary, remember whenever you're working with variables, you need to define your variable. Never lose track of what x represents. It'll help you through the solving process. Also, when you're setting up your equation, remember we were working forwards when we were setting up the equation here. So x divided by 3, the first thing that happened was the dividing by 3, and then the plus 4, and then the multiply by 2 to get to the answer. However, when we were solving it, we had to work backwards to undo each of these steps and use the opposite operations. All right, thank you for watching.